Hey everybody, it's Mick Liubinskas here from Climate Salad. Everyone knows I love talking about innovations across all the climate spectrum, particularly the massive challenge around energy. And today I'm joined by the team from P2AgentX to talk about autonomous solar farms. Jim, can you give us a little quick introduction to yourself and P2AgentX?
Yeah, thanks, Mick, for having us on the Climate Salad videos. So at P2AgentX, we are actually building an army of AI agents that can constantly access live solar farm data and instantly spot faults as they appear. And very soon, we will have robotic systems that will inspect those faults, and eventually, in the near future, we can even fix them. So imagine a solar farm that can monitor, diagnose, and repair itself. And that's our vision.
Fantastic. It was very interesting. We were just chatting about AI yesterday and saying how it's been used to make funny jokes and more cat videos, as if the world needs that. What can it actually do to help climate change and solve that massive challenge? We know the solar panels are out there, and we know they're out there in the millions and getting more and more. How, in terms of actually autonomous solar farms, like tell us about the background. How does it currently work, and tell us how you're trying to change it.
Yeah, I mean, when utility scale solar especially started about 10 to 15 years ago, the industry was primarily focused on one thing, building capacity as fast as possible. So gigawatts of solar were deployed globally, but the tools to operate and manage those assets did not evolve at the same pace. So today we have this interesting situation where solar farms worth hundreds of millions of dollars are often still operated with spreadsheets and static dashboards and manual engineering analysis. So in many solar portfolios, the operational model still relies on subcontracted O&M engineers manually analyzing the data from the SCADA systems and compiling performance reports. And this actually takes days or even weeks to produce, especially when you have a lot of solar farms in management. Um, so the challenge has been that the solar farm generates a lot of operational data. So these come from inverters, trackers, weather stations, and thousands of strings of solar panels. But when that data sits in disconnected systems or spreadsheets, it becomes very difficult to quickly identify what's really happening inside the plant. So at the same time, when many faults in solar farms are actually quite subtle, so it's very hard to notice them. So things like, for example, soiling or string falls or equipment degradation can quietly reduce the production. Like just to give you an example, a dust accumulation alone can cause about 5 to 10% loss in energy loss globally. So that actually translates to billions of dollars in lost revenue across the industry, right? And
Yep.
because inspections are often manual and periodic, these problems can remain for months. So our mission is to actually, turn this, very reactive based operations into full an autonomous operational method.
Yeah, that's great. It sounds like it's just we've got to bring it into the 21st century first, and then move it towards the 2050 goal of high efficiency as well.
Yeah.
Bram, I just put over to you. I'd love to tell us about your role with P2Agentix, and I know you've said that AI is the brains and robotic hands for solar farms. That's what P2Agentix is aiming to do. What does that mean in practical terms?
Yeah, first of all, I will do a quick introduction. So I'm a professor at UNSW, and in 2022 we were awarded a project from Arena to really to go to the highest precision yield modeling and also combined with financial modeling. And this project yeah, started in 2022, and very quickly we identified that it also had massive opportunities. If you have these high precision models, you can extract a lot more value of existing assets. And that's how P2Agentix was formed. So we founded the company. So Jim and I founded the company last year only. We're not even 1 year old. We founded in the end of May
Yeah.
last year. And really, it's aimed at using these AI tools to extract maximum insight from the farm. Because like for myself, I've been working in the solar field for 25 years. So there's a lot of signatures that like failure modes so on a cell module level, inverter level that you can pick up that impossible to do if you use the spreadsheet that Jim alluded to. So that's what we see as these brains. So we have dedicated AI agents that are sniffing for these faults to identify them early, because a lot of money is lost by faults that occur and then already identified and mitigated, yeah, sometimes even months later. But also, I mentioned that we focus on so performance yield and financial yield, because although I'm a scientist, I love to see the asset performing always to the max, but the economics, that's what's driving the world. That's what's driving us towards, yeah, a clean future. So we also have to identify, like, if it's a small fault that is costing us a few dollars a day, then maybe it doesn't make sense to fix it now and just wait when it's economically the most feasible. So we also include that into the brain. But then with the development of robotics, of course, there's massive opportunity, because in Australia, a lot of these farms are in locations that are quite hard to get to, really expensive to get to, requiring quite expensive personnel. And actually, we cannot find enough people. So there's a massive opportunity there for robotics to reduce that cost. And at first, it will just be this visual inspection, just to narrow down what the problem is, so we can fix the problem quicker. But very quickly, we feel that robotics can fix stuff on site, and that overall will significantly reduce the operational and maintenance costs of a solar farm. We feel at least 40%, but likely even more. And we're roughly spending globally like $6 billion a year on that, so which is growing exponentially. So that's a massive opportunity. And we just don't have the people. So it's not that we're replacing jobs. So the people are not there.
Yeah, that's an interesting point. I think especially there's a lot of questions obviously around AI and robotics and their impact on jobs, and the same question applies in terms of picking fruit efficiently. You just there's just not there's just no human labor on the planet that can be efficient enough to pick the fruit and vegetables efficiently enough. And agree. There's just I saw that it took us like something like 30 years to go to a terawatt of solar, and then it took us another just another 2 years to double that again. So yeah, the scale is getting so big that we need these kind of tools. Hassan, I want to bring you into the conversation. Can you tell us, you're not working for P2AgentX, but you're looking to be a happy customer. Can you tell us about you and your role, and what was it about P2AgentX that made it the product you wanted to go with?
Thanks, Mick. Well, uh, from the asset perspective, I'm the CEO of Epico, which is I would say a medium to large scale developer who functions more in the Middle East, around Middle East and North Africa. So one of the major things that we always look at is, with the growth, with the multiple solar farms coming in our portfolios, is the expectation that operation of solar plants is something, or at least that's that stereotype that was always the thing when solar systems came into the market, is cost of operation is minimal. What we found out is with the scalability of solar farms, the thing is, it adds a lot of complexity to the monitoring. We do need to have a constant monitoring, and a constant monitoring to a different region also adds more complexity to the whole thing. It consumes a lot of time. So you can have medium scale solar plants, small scale solar plants, large scale solar plants. We operate from medium to large, so we're talking about 10 megawatt up to even 600 megawatt solar plant. And with medium scale, as we speak, you would need to minimize operation and monitoring. Unfortunately, that has been proven not to be that easy. False detections can happen very easily. And by the time you identify fault, as you know, it's a plant that generates energy, and energy is equivalent to it's basically it's money. That's where we make our money there. And as you keep losing it, so you're losing time to identify the problem. Now, be it fault, be it soiling, be it mismatch between what was expected, adjustment, time for the technicians to go to the site, to go there. All of that is loss of time and inefficient, I would call, use of time. What that's has led us to actually go to the market, try to experiment with the tools, see what's going on. And we ended up going with the P2AgentX. We found out that the tool is actually very useful, very precise. It's based on heavy physics that also utilizes AI. We've gone with them with many exercises, and we found that the tool is actually working very nicely. And the saving potential is quite high. I mean, just to give you an example, at least from medium scale to large scales, and if you say 1% lose of energy in a 600 or 500 megawatt can be easily equivalent to $1 million or 1.5 million. So that, of course, varies from Australia to Middle East to other countries, and that's just 1%. And usually 1% should be acceptable, but it's a huge shift in revenue. And that's why we believe, I strongly believe that the shift to efficient, smart AI tools is one of the main key that the market is not only us. I think all the market is looking at that shift where we not replace, as Bram says, not replace manpower usage, but make it more efficient, more precise, and much more quicker to identify the problem and even predict it, as we say, before it happens.
Yeah, that's great. I think there's no doubt that even if solar was a minor part of the energy mix 12 years ago, we know now it's just hitting 50% in a lot of countries and higher, and it's got to go even higher. Got to go much higher than that. Yeah, Jim, back to you. Just a little bit on the give us a quick past, present, future. How did you know when this was going to be possible and worthwhile doing is a big problem? Because you obviously, Bram's saying it's only a year old, but you've all been working in this space for a long time. When did that insight hit you? Where are you now with the product and value? And can you give us a bit of an insight into what's coming next?
Yeah, thanks for that question. So I've been, actually in the industry after I did my PhD on this PV module performance and reliability, almost 8 years. So I was lucky enough to be involved in one of the largest solar farms in the world. It's about 5,000 megawatts, based in Dubai. So after that, actually, I saw what are the current tools and offerings out there when I was actually trying, we were trying to build and decide on tools. And then also coincidentally, my time at UNSW, we actually spent working on developing these physics-based modeling tools. And at one point, when we started to see AI coming in, I exactly remember close to the end of 2023, we said, hey, why don't we start combining these two? And so that's when the development of AI agents, and we really started to see the progress that we made. So we've been kind of riding the wave in parallel with how the AI agentic systems are being developed. And also then, then parallelly, I think close to 2024, even 25, we started to see how robotics are also becoming quite efficient and cheap, and also is able to do things that were never thought were it could do, right? So these two things together, I feel like the real future is where a lot of the work will be done autonomously. And so what that really means is that if AI would diagnose the problem continuously, and the robots could actually physically inspect and verify these issues in the field. And so what that really means is you can now close the loop. So basically you have data, then decision and action. All right. So you don't need to wait for weeks or for reports or periodic inspections. The solar farms could essentially monitor itself in real time. So that's the vision we are working towards, a solar farm where it understands its own performance, detects issues instantly, and deploy robotics inspection when needed. So as I mentioned earlier, so we really want to see the industry move from reactive operations to truly autonomous solar infrastructure.
Yeah, that's great. I often tell people that a lot of this technology has been around for a while, but we just haven't invested in scaling it and optimizing it. And that's actually really exciting because there's whether you're talking about recycling it or having sort of proactive maintenance on it as you're talking about. I think that's a great outcome. That's going to have huge impacts because obviously. Yeah, the old system kind of seems simple. You have a big power station fueled by coal, and you throw a lot of power down some wires, and then you can charge your phone. But it's actually pretty inefficient, and the new systems can be really efficient. It's just got to be done differently. Um, Bram, to bring you into the conversation again, if you think about farms now, we know there's obviously this macro problem, and you've got this great product that can help them. How are they? How are they losing money now? How can P2AgentX step in and help them in their biggest areas?
Yeah, I think like in Australia, a lot of farms are losing money because of curtailment, because of market situation. We don't have a solution for that, but it would be great if we would. But
Mm.
it actually could you could make you could make decisions that extend the lifetime of the farm. So if you're not producing, so that's something we're also working on. So that would be advanced tracker algorithms, for example. But if you look at just globally, where do solar farms lose a lot of money? So it's up cost money, so it's O&M cost and opportunity cost. So like the asset not performing up to its potential because of soiling, inverter, of availability, mainly due to inverters, which is the main issue. And of course, that's what we squarely focus on. We will slash O&M costs by going to fully autonomous operation. And the availability, yeah, we'll be able to identify issues a lot earlier. So like if there's an inverter offline or a string, we'll be able to detect that very early. But then also because we know the fingerprints of many different failure modes, we will be able to detect them well before they show up. So you can do preventative replacement of key components. And that's again mainly many inverters. So that's where we're squarely looking at. That's a above $10 billion opportunity at the moment, growing exponentially. So that's where we really are squarely focused on, and that's where we can provide a lot of value already.
Fantastic. So Hassan, in terms of that question back to you as an asset owner of solar, like what for all the other solar asset owners out there, what are the things you're doing differently now, and you get people and you encourage people to think about in terms of getting the maximum watt per dollar out of your assets?
Well, it's true that it's one of these hidden issues that, as an asset owner, it's always it's always in the back of our mind. It's a money loss that you don't feel it until it hits you at the end of the year, and when you start to compare how much you should have gained and against how much you actually gained, you get shocked. And then you go ahead and you evaluate yourself as could I have done better? What uh, what 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 things gone wrong? And then you start to evaluate, and you go into these cycles. The only thing is, solar farms are environmental kind of it's plants. So the energy is the sun. So when it's gone, it's gone. It doesn't come back. You lost the opportunity. You cannot recover. And that's where the issue from our perspective is. So the sooner we know what's the problem is, the sooner we can identify it. I don't, in my principle of operation, I don't want to wait for 1 week to understand that I have a fault and then fix it. I want my problem to be shortened from 1 week to even 1 minute to one hour. That's when I want to see where the problem is. How can I trigger it? How soon I can go and fix it? And how much I can save against that? That's why we believe that we need to go to the right assessing tools to assess these problems, to find where the root cause of this problem, predictive, preventive, and all the other things. So that's from the perspective of managing, and also we have the perspective of reporting. We need to know what's happening in the plant on the spot. So there are tools in the market there to do. We need to make decisions, fast decision. You know, initially the way if you ever go to a multi-site operating central operating room for solar plants, you will see 2 or 3 guys sitting, or something, in many cases one guy sitting, one technician or engineer with multi-screen, and every time he's monitoring one plant and he's waiting for alarms to happen, or he goes to home with his phone always in emergency, wishing that nothing comes to him to alert him in the middle of the day that there's a problem and you have to run and go and see what's going on there. So you need to operate in a much more efficient environment and be very fast and precise in making your decision. So from our perspective, this is the tool that we want to adapt, a tool that is precise, efficient, make decision. I mean, for us, even making decision in our place that is a proper decision could be a much safer route to go into that, as long as this decision is based on logical, rational, physical approach to health the plant. And we also want to be one of the very earliest adapter of AI tools into our plants. And we are one of the early adapters into the market.
That's fantastic. Well, I think it's really clear, obviously, as solar continues to scale out, that we've got to work on all parts of the stack, and bringing in these new technologies such as AI and robotics to do this work is not just important. I think it's necessary. Yeah, Jim and Bram, thank you for your hard work at P2AgentX. Hassan, thanks for sharing your customer story. It's so important, and it's actually really exciting that we're moving out of the labs and into in this case, into the solar farms, and having a really, really big impact. So great to see. I'm looking forward to the growth this year. I think it's from what I've seen from the UNSW companies coming out, they pick up a head of steam and lots of momentum going to what I think is a really, really strong period of growth. So Jim, Bram, Hassan, thank you so much for sharing. And yeah, again, looking forward to a big 2026.
Thank you very much, Mick, for having us.
Great. Thank you.